Shall I start the class? Okay, we'll wait a few more minutes. I think I am audible.
Yes, ma'am.
In the last class, we have seen how to generate the frequent item sets. Okay, any doubts in the previous class? Okay. So now after generating the frequent item sets, we need to generate the rules from that frequent item sets. So you have some F number of frequent item sets, and from the F number of frequent item sets, you are taking a subset of frequent item sets which we are representing it as alpha. On the right hand side, that is on the consequent side, we are taking the subsets of frequent item sets as alpha. So the remaining will be F minus alpha, and we are framing the rule. And that is F minus alpha associates alpha. If this rule to be hold, you need to check whether the subsets of alpha, that is alpha sub, which we are representing on the right hand side, and the remaining will be F minus alpha set, must also hold. I'll repeat. There are F number of frequent item sets. Out of F number of frequent item sets, we are taking the subsets of frequent item sets, that is we are representing it as alpha, and we are framing the rule F minus alpha associates alpha. If to hold this rule, the rule that is F minus alpha sub associates alpha sub. What is alpha sub? Subsets of this alpha must also hold. That means in while generating the rules also, we are going for downward closure property. Is this point clear? Any doubts? Okay. So this is the algorithm for association rule generation, and I'll explain this through example. Okay. This is our data set, and as usual, minimum support is 30% and minimum confidence is 80%. So the frequent item sets are in F1, beef, cheese, chicken, and clothes and milk, with the support 4, 5, 3, and 4. So in the joining step, we got F2 and F3, okay? And these are the frequent item sets at third level. Now we have to generate the rules. Rule 1, Generate all the rules with this frequent item sets: chicken and clothes, chicken and milk, clothes and milk. Okay, all the three sets we have taken, and the remaining, this is the subset. Okay, and the support is 3 by 7, confidence is 3 by 3. So due to the minimum confidence requirement, we are taking only rule 1 and rule 3. Rule 2 is not satisfying the minimum confidence requirement. So we are eliminating the rule 2. So rule 1 and rule 3. Anyone? 1 minute. I think everyone has joined in. Anyone yet to join? No, Kada? Sai Krishna, your voice is too low. Ah, yes. Shall I proceed? Okay, right. So in rule 1 and rule 3, what are the consequences? Milk and chicken, right? So I am taking milk and chicken as one set and storing in the variable called as h1. Okay, h1 consists of all the consequences of one item sets. So I have taken all the consequences of one item sets here. Okay. The next step, AP gen rule is called, and we are producing the H2. And so we are combining all one item sets into two item sets. Item sets containing two items. So from this H2, you need to generate the other rule. So we have only two items here. So I am generating the rule 4, that is clothes associates milk. Milk and just a minute. What is our consequence? Chicken and milk, kada? Okay. So with this, what is our chicken close to milk? We got chicken and milk. This is not milk close. This is chicken milk. So from this H2, we are generating the consequent chicken milk with the remaining one clothes. Is this point clear? Here I have written a wrong rule. Okay. Not clothes associates milk clothes. Clothes associates chicken milk. Okay. So the three association rules are generated. That is chicken, clothes, milk in F3, and we have generated three rules. So first we have generated with the minimum confidence rule 1 and rule 3, and from the consequence we have generated H1, and we have joined, giving rise to H2, and from that consequence we have generated the rule 4. Okay, so totally we have generated three rules. So for generating the frequent item sets, what is required? Support is required. And for generating the rules, confidence is required. So in generating the frequent item sets, again we are not calculating the support because in the frequent item sets itself, we have calculated the support. So, Apriori algorithm, what is the main use of Apriori algorithm? Even using Apriori algorithm, we can scan the large data sets, and the time complexity is linear in time. But the main disadvantage is it needs more passes. So the main time complexity is given as big O of 2 of m, and it exploits the sparseness of data. And when we are generating the support and the confidence, we are taking the high values and high minimum confidence. But still we are producing the huge rules. And one thing, next slide, Adina. Okay, right. So, see, when you are generating the frequent item sets or the rules, what is the main thing? Support and confidence. So when you are going for support and confidence, you need to decide what values you have to give for minimum support and minimum confidence. How you will decide? See, in our previous example, we are taking minimum confidence of as 80%. Why can't I take it as 20%?
If we take as 20%, the rules won't be that appropriate. Means we won't
Yes.
get the required results.
So obviously, we'll take more than 50%, right? So that means we are taking high minimum support and high minimum confidence. Even by taking high minimum and minimum confidence, we can able to generate huge number of rules out of it. So different data formats. What data format you are using here? What data format? Transactional data format, which is in the form of rows. Okay. So this is the data format you are considering. This is the transactional data format where your A, B, C, D, E, F are all items. Now you have a table form. This is a table, okay, and you need to convert it into transactional form. How you will convert? Any idea? You will apply the association algorithm on the transactional data, but we have the data in the form of table. That table you need to convert into transactional form. So for this, see, for converting into the transactional form, take the values of the particular attribute along with the attribute name. So this becomes one item. Attribute 1 along with this, the value of the attribute will become one item. Attribute 2b will become another value. Why not we are taking the single values A, B, D? Why we are going with the attribute values?
Ma'am, maybe attributes function like they play the role of a key to identify them uniquely.
Yes, to identify the
Uniquely, ma'am.
yes, unique label. See, if you take, if I consider only the values, what values I'll get? A, B, D, B, C, E, right? Then what is this B and what is this B? You cannot identify. Yes, that's why when you are converting the data from the tabular form into transactional form, take along with the attribute values. Very good. Now, if I have a transactional data, how you will convert into tabular form? This is you have to analyze. I have given the transactional data. Sorry, what is tabular data? Uh, representative, we have converted tabular data from the transactional data. Again, from the transactional data to tabular form. How you will convert? Transactional data means these values are not there. In this form, I have given you the data, transactional form, convert into tabular form. ఆలోచించండి ఎలా కన్వర్ట్ చేస్తారు. Have you understood how to convert tabular data into transactional form? Now convert transactional data into table form. ఆలోచిస్తారా క్లాస్ ఆన్సర్ or shall I tell now itself?
Ma'am,
Will you try?
is it that we take the first of the pair and keep it as column
See,
heading?
1 minute. Who is answering?
Harshit, ma'am.
See, I am not giving the data in this form, in the that is attribute value form. I am giving the data in this form. Only the
Okay.
items are given.
Okay. So, ma'am,
Now
but
this
you
transactional
previously
data,
mentioned transaction form has key value pairs, ma'am.
what ma?
Uh, like you previously mentioned, transaction form consists of key value pairs.
Transactional values does not contain key value pairs. When you are converting this transactional data, that is A, B, these are items, right? Your
Yes, ma'am.
transactional data will be in this format. This is your transactional data, if you can make. Okay, this is your transactional data.
Yes,
Okay,
ma'am.
this transactional data you are converting into tabular form.
Okay, ma'am.
So how you will? Sorry, 1 minute. You have confused.
Oh,
The
sorry.
first thing I explained is converting the tabular data into transactional form. When
Yes,
the
ma'am.
data is in tabular form, obviously you will have column names. Okay.
Yes, ma'am.
So this forget about transactional data. This tabular data, when you are converting into transactional form, you need to consider the key values. That means you need to, not key values, you need to take along with the attribute values.
Okay, ma'am.
I have told you from tabular to transaction.
Yes, ma'am.
You have to take it from transaction to table.
So, like when transaction form is given, it is not mandatory that we get in some key value pairs. We can get only items also. Is that like when we need to convert from transaction to tabular, ma'am?
Ah,
It is not mandatory. We get some key value pairs, right, ma'am? We
no,
may get
tabular.
only items.
Do you mean, what do you mean by key value pair? Table means you'll have a column name and the value.
Yes, ma'am. Yes, I just
Then
got
how will
confused.
convert?
I just got confused.
What ma? I couldn't able to listen.
No, ma'am. I just got confused.
Have you understood what I said, everyone?
Yes, ma'am.
Okay, right. So shall I give the answer? Item names as column names. మీకు ట్రాన్సాక్షన్ 1 ట్రాన్సాక్షన్ 2 అని ఎక్కడ ఉందమ్మా టేబుల్లో? ఇది ఫర్ ఎగ్జాంపుల్ ఏబి ఏసి డిఈ అని ఉంది. ఓకేనా? ఇది మీ ట్రాన్సాక్షనల్ డేటా. ఇప్పుడు టేబుల్ డేటాలోకి చేంజ్ చేయాలి అంటే ఎలా చేంజ్ చేస్తావు? కాలమ్ నేమ్ ఫర్ ఎగ్జాంపుల్ T1 అని పెడతా అంటున్నావు. అవునా? అంతేనా? T1 అని పెట్టి okay. Okay, right. I'll tell you. Very good attempt. Take all the column values, all the transactional items, all the items as a column values, column names. A is the column name, B is the column name, again C is the column name, E is the column name. These are the items that are getting repeated. So all the unique items take as column names. And in transaction 1, say transaction 1, transaction 2, transaction 3 are nothing but the rows in the table. Avuna? So if A is present in the transaction 1, give the value as 1, otherwise give the value as 0. So you are converting in a binary format. Is this clear? Right. Mining with minimum support. See, till now, when you are mining this data, you might observe that whatever do your data in data mining lo kani, web mining lo kani, whatever examples you have taken, what type of examples are there? Day-to-day groceries, that we frequently purchase. Then not only day-to-day groceries, we purchase some rare items like we may purchase a furniture, we may purchase a cooking pan. Even that rare items has to be mined. Then what are the problems that we face when we are trying to mine the rare items? Let us see. Have you understood the question? Right. So till now we have only used a single minimum support. In the single minimum support, we are assuming that all the items that we are purchasing are of same nature. That is, they are all frequent. But the purchase pattern may include the rare items also. That means the nature of items we are purchasing are not of same. That is, for example, in a supermarket, people may buy food processor, cooking pan, along with the bread and milk. So if we set the minimum support too high, these rare items may not be included in the frequent item sets or in the rules. So if you to find the rules that involves both frequent and rare items, minimum item sets has to set low. If we set the minimum item low, then you will get many number of rules that leads to combinatorial explosion. If you have too many of the rules, then you cannot identify which rule is useful to us. Have you understood? I want to include the rare items also. If I want to include the rare items and I am setting the frequent item sets as high, that rare items will not be included in the rule. If I am setting the rule as too low, then it may include every item so that we cannot conclude anything from that. One of the important question, what is the rare item problem? If you have any doubt, ask me again. Shall I proceed? Yes. Okay. So for example, assume that we are setting a very low minimum support of 0.005%, and we found that these following frequent item sets: food processor and cooking pan. As we have set the minimum support as 0.05%, along with this frequent item sets, we'll get another frequent item sets F1 and F2. That is, F1 includes these item sets: bread, cheese, egg, milk, sugar, and butter, and bread, egg, milk, and cooking pan. Say, knowing that these frequent item sets, bread, cheese, egg, having 0.07%, it is of no use, because the frequent item sets minimum support should be greater. But as we have set the minimum support very low, we are getting these items for this minimum support, which is of no use. Again, we want to find the frequent item sets which is either frequent or either rare, but not the combination of the both. Because see this combination: bread, egg, milk, and cooking pan. This combination is very rare. Okay, either the frequent item set should be bread, egg, milk, or cooking pan and food processor, but not the combination of the both. Okay, you should place the items in the supermarket which is frequent or which is rare, but not the both. Have you understood F1 and F2 problems? Try to understand F1 and F2 problem. Is my voice audible now?
Yes, ma'am. It's clear now.
Okay. No doubts. Shall I proceed?
Yes, ma'am.
Okay. So this type of dilemma is called rare item problems. So uh, what is the solution for that? Anyone is there whom I need to admit? I'm getting some sound. I'll check. Yes. Okay. So when you are using single support, you are getting this problem. So the solution for this is minimum items, sorry, multiple item support, multiple minimum support model. The minimum support of a rule is expressed in terms of MIS. What we'll do is, for each item, we'll give some minimum item support. That means that we are providing different MIS values for different items. What is the main use of MIS values? The main use is that you are providing the minimum item support for different values, so it will achieve the different support requirements for different rules. So this model will help us in finding the item supports which are rare as well as which are frequent, and it avoids generating too many meaningless items. So when you are using minimum item supports, combinatorial explosion can be avoided, and even the F2 problems can also be avoided. And for F2 value, to prevent the F2 problem, we'll go with another constraint called as support difference constraint. దీని గురించి తర్వాత వస్తుంది. First we'll study only F1 problem, but remember this. For eliminating F2 problem, we use support difference constraint, that is maximum of support of I minus minimum of support of I should be less than or equal to 5, where 5 is a user specified maximum support difference. What is that? We'll see in next slides. So let MAS of I be the MAS values of items I. The minimum support of the rule R is the lowest MAS value among the items in the rule. See, for example, I1, I2 and IK associates IK plus 1 IR satisfies the minimum support if the rule's actual support is greater than or equal to minimum of MAS I1, I2 and so on. So when we are specifying, for each item we are specifying some MAS value. Okay. So the minimum of these MAS values should be less than our actual support value while taking some rules. Okay. So actual support, whatever we are getting, our support should be greater than the minimum support of all these values. So for using this minimum support, we can achieve the higher minimum support for frequent item sets and lower support for rare items. So consider this item sets: bread, shoes and clothes. And let us define the minimum item supports for bread is 2%, shoes is 0.1% and clothes is 0.2%. So I am writing a rule: clothes associates bread, which is having 0.15 support and confidence is 70%. But what is our rule? The minimum of MAS values should be greater than actual support. That is, actual support actual support should be greater than the minimum of MAS values. So minimum of MAS value is 0.2%. This 0.2% should be less than our actual support. But actual support here is less than 0.2%. So we are eliminating this rule. This rule should not be considered. Is this point clear? Or shall I repeat? Chepama. On actual support should be 0.5. This is not greater than 0.2 kada. Just a minute. Give me 1 minute. My battery is low. Yes, repeat the question. Yes, MAS value is 0.2. No, this in this example they have not considered the data set. Just they have given 0.2. Oh, why not consider cheyalana? See, MAS values. This is just for support. Support we are taking minimum. In the previous examples also we are taking only 30%, right? 30%. So here you can represent For each item, you can take the minimum values 5%, 0.5% or 5%. Okay, minimum you can specify, because for each item you are specifying. In the previous case, for the all item sets you are considering, but all item sets, the frequent item, you are taking minimum of 30%. But here you are considering for individual items, so 30% is not required. It less than 10% is enough when you are considering single items. Okay. And any other doubts?
Ma'am, uh,
Ah,
are we generating rules here, ma'am, or just checking if the given rule is satisfying minimum support, ma'am?
we are taking the rule whether see here what it is saying. For the rule itself, we are checking the actual support values.
Okay.
I think
Okay.
your doubt is for generating rules, you need to consider confidence, right? You are the
Yes,
question
ma'am.
doubt.
Yes, ma'am.
But here, as we are considering minimum item supports to satisfy the rules, this condition should be satisfied.
Okay, ma'am.
Okay. Now, see the second example. Mali, ఇంతకు ఇంత ఎటుగా వస్తే ఎలా అమ్మ అందరూ కనిపించట్లేదు. నో వన్. No one is there in waiting room. సాయి కృష్ణ నీకు కనిపిస్తున్నారు ఎవరైనా? లేరమ్మా. అడుగుకొని ఉన్నారమ్మా. మినిమైజ్ చేశాం కదా స్క్రీన్. ఓకే, రైట్. See here, when I am taking close associates shoes, and now I think someone has come. ఆటోమేటిక్ అడ్మిషన్ ఆప్షన్ ఉండదు అందులో. ఇన్స్టెడ్ ఆఫ్ ఎవ్రీ టైమ్ ఐ am clicking admit. అదే జూమ్ లో ఉంటుంది, ఇందులో లేదనుకుంటా ఆప్షన్.
ఉండాలి మ్యామ్, బట్ ఎక్కడ ఉందో ఎగ్జాక్ట్లీ తెలియదు మ్యామ్.
ఓకే, రైట్. ఓకే, నెక్స్ట్ టైం ట్రై చేద్దాం. అది షెడ్యూల్ చేస్తే షెడ్యూల్ చేయడానికి వస్తుంది అసలు ఇన్స్టాల్ చేయకుండా వెబ్ యాప్ లో. నేను ఎక్స్టెన్షన్స్ కూడా డౌన్లోడ్ చేశాను, కానీ మన సిస్టమ్స్ ఎక్కడ వర్క్ అవ్వలేదు. ఎక్స్టెన్షన్ లో నాకు అసలు కనీసం ఇన్విటేషన్ పంపించడానికి కూడా రాలేదు.
మ్యామ్ క్యాలెండర్ లో ఆ స్లాట్ లో జస్ట్ మీటింగ్ స్టార్ట్ చేసామని పెట్టి గెస్ట్స్ కింద ఈ ఇన్వైట్ లింక్ కాపీ చేసుకొని పంపిస్తే సరిపోతుంది మ్యామ్. ఇంకా ఆటోమేటిక్ యాడ్ అయిపోతారు మ్యామ్ అడ్మిట్. ఎక్స్టెన్షన్స్ అవన్నీ అవసరం లేదు మ్యామ్.
సాయి కృష్ణ ఎక్స్టెన్షన్స్ లో రికార్డింగ్ ఆప్షన్ ఉంది మేడం. ఇవన్నీ మాట్లాడుతున్నప్పుడు స్టాప్ చేసి సాయి కృష్ణ టేకింగ్ ద మినిమం వాల్యూ. ఓకే, 1 and 2 ms values are minimum of this 10%, right, which is greater than 9%, so we cannot take this. Have you understood? Shall I repeat? Others not answering. I'll repeat. 1 and 2 is having the support of 9%. What is minimum of MAS of 1 and MAS of 2? It is 10%. The actual support should be greater than the minimum support, but here the MAS value is greater, minimum of MAS values is greater than the actual support. So you cannot consider 1 and 2. But take 1, 2 and 3. Consider 1, 2 and 3's support is 9% only. Okay. So the minimum of MAS of 1, MAS of 2 and MAS of 3 is 5%. Okay. So this value is less than our 9%, so you can consider 1, 2 and 3. The downward curvature property is no longer holds in MAS when you take MAS values. Is this point clear?
Yes, ma'am.
Very good. So to deal with this problem, what we need to do is sort all the items according to their MAS values first. And when you are sorting of these items should be considered in the entire algorithm. Only that sequence should be considered. తర్వాత మీరు గుర్తుంచుకోవాల్సింది ఈ పాయింట్స్. Explain this with an example. So first sort the items according to their MAS values and scan the data, and next candidate generation at level 2, prune the data. So everything you know, but this slide is very important. For each subsequent item j in M after I, if j dot count by n is greater than MAS of I, then j is also inserted into L. I'll explain this.
మ్యామ్ మీ వాయిస్ స్లైట్ గా బ్రేక్ అవుతుంది మ్యామ్.
ఇప్పుడు క్లియర్ గా ఉందమ్మా?
లేదు మ్యామ్,
బ్రేక్ అవుతుంది.
లైట్
ఇంకా
గా
బ్రేక్ అవుతుందా?
ఎస్ మ్యామ్.
ఎస్ అంటే బ్రేక్ అవుతుందా క్లియరా?
అంటే లైట్ గా బ్రేక్ అవుతుంది మ్యామ్. ఇంకా
I'll take my laptop. Now?
నౌ ఫైన్ మ్యామ్.
Okay, right. So consider these items 1, 2, 3 and 4. Okay, and with these MAS values, and assume that our data set has 100 transactions. The first pass gives us the following support of count. This values is already given. It is item set 3 count is 6, 4 is 3, 1 is 9 and 2 is 25. And why we have taken this 3, 4, 1 and 2 but not 1, 2, 3, 4? Because we are placing them in their the sorting order. Now you need to first you have sorted according to their MAS values. Next, L value you need to consider. How you will take this MAS L value? That is the main thing here. For considering the L value, how what the values will place in the L values? For subsequent item in J in M, so these are M values. If J dot count by N is greater than MAS of I, this is consider this value as I, and the subsequent value this is as J. Okay, the first value as I, because we have sorted, the first value will be the I value and the next value will be the J value. Then For inserting the value into the L, what is the rule? J dot count by n should be greater than MAS value of I. What is MAS value of 3? Is 5. But according to the rule, this J dot count should be greater than MAS of 3. But here it is less. That's why we have not included in the N. Have you understood this point?
Ma'am, please repeat that one again.
ఒక్క నిమిషం చూడండి అమ్మా. To insert the value into L, the rule is J dot count, support count, should be greater than MS value of I. J and I. Okay? ఇక్కడ I ఏమో 3, J ఏమో 4. ఓకే, దీనికి ప్రీవియస్ ఏది లేదు కనుక 3 విల్ బి ఇంక్లూడెడ్ ఇన్ L. నెక్స్ట్ 4కి వచ్చేటప్పటికి 4 బికమ్స్ J అండ్ 3 బికమ్స్ I. Force support count should be greater than the MAS value of 3. కానీ ఇక్కడ force support count is less than the MAS value of 3. అందుకని 4 we have not included in the L. Support count, J's support count should be greater than the MAS value of I. ఇది I, 3 is the I, J is the 4. ఒకసారి, have you understood? Here J's count is 3. Okay, so the previous value I 3, ఇది 3 యొక్క MS value ఎంత? 5%. MS value greater ఉంది, బట్ మన రూల్ ప్రకారము లెస్ ఉండాలి ఇక్కడ. ఇది 1 minute. MS value should, J's count should be greater, but ikkada J's count less ఉంది. 3 and 5. That's why we have not included 4 in L. చెప్పమ్మా. What is? ఏంటంటే పర్సంటేజ్ కనుక్కుంటున్నాం కదా, మా పర్సంటేజ్ లో ఎన్ని నెంబర్ ఆఫ్ ట్రాన్సాక్షన్స్ డేటా సెట్. ఓకే, ఎనీ డౌట్స్?
మ్యామ్ ఇది అర్థమైంది, బట్ ఇది ఎందుకు చేస్తున్నాం మ్యామ్ ఈ స్టెప్?
ఇది అదేంటి, ఒక నిమిషం చెప్తున్నా ఉండండి. డౌన్లోడ్ క్లోజర్ ప్రాపర్టీ సాటిస్ఫై చేయట్లేదు కదా.
అవును మ్యామ్.
డౌన్లోడ్ క్లోజర్ ప్రాపర్టీ చేయట్లేదు కాబట్టి ఏది, where is that? Yes, so we are going for another algorithm.
ఓకే, అప్రయోరి కాకుండా వేరే అల్గోరిథం.
వేరింగ్ ఇక్కడ ఇప్పుడు చూడండి, F2 ప్రాబ్లమ్స్ ని రెక్టిఫై చేయడం కోసం మళ్ళీ తర్వాత స్లైడ్స్ లో వస్తుంది అన్నాను 5 వాల్యూ. ఇంకా అవన్నీ చెప్పాలి మీకు. సో F2 కూడా రెక్టిఫై చేయాలి. డౌన్లోడ్ క్లోజర్ ప్రాపర్టీ సాటిస్ఫై చేయట్లేదు కనుక వీఆర్ ఇంట్రడ్యూసింగ్ అనదర్ స్పెషల్ వేరియబుల్ కాల్డ్ as L, and for inserting the values into the L we are following that rule.
Okay ma'am. And downward support, downward closure the cheste, I mean like if it satisfies only we can use a priori ma'am, unless we can't ma'am.
Ante MS value use చేస్తున్నప్పుడు downward closure property will not satisfy, may not satisfy. ఒక్కొక్కసారి satisfy అవ్వచ్చు, మన minimum items అకౌంట్స్ ఇచ్చిన దాన్ని బట్టి, కానీ mostly may not satisfy.
Okay ma'am, that's it ma'am.
Okay ma'am, just a minute, where is my slide? Okay, now see, this is only in the first initial stage while finding the L values ante. Okay, and from this you are generating F1 because మళ్ళీ frequent items generate చేయడానికి the minimum rule. So we are not including 1 in the F because its support is less than minimum item support.
మ్యామ్ వాయిస్ బ్రేక్ అవుతుంది మ్యామ్ మళ్ళీ.
Have you understood how you have generated L value? Yes? Okay. Then from that N value, you are generating the frequent item sets, that is F1. So in F1, we have not included 1 because its support count is less than MS value. L value generations ki rule veru, frequent item sets generation ki rules veru. Frequent item sets generations ki manaku telisindi entante the support count should be greater than MS value. But here the support count is less than MS value, so I have not included 1 in my F1. Okay, is this clear? Shall I proceed? Right. Level 2 candidate junction. So you are taking an argument L and we all frequent we have frequent sets. And now we are introducing the value. What is 5 here? Support different constraints, and we are using a 5 value to eliminate the F2 problem. MS of 1 is 10%, 2 is 20%, 3 is so on. So level 2 candidate generation will produce 3 and 1. It's the main point. 1, see, I can take 3, 4, 4, 1, 1, 2 or any combinations, right? We are not including 1 and 2 because the support count of item 1 is only 9, which is less than MS value of 10. Sorry, MS value of 1. Have you understood this point? Have you understood why we have not included 1 and 2? See, 1 and 2 is not candidate because the support count of 1. What is the support count of 1? Is 9. See, when you are generating the rules, even you need to consider the minimum values, right? The support count should be greater than the MS value, kada? మరి ఇక్కడ less అయింది కదా. So we are not including 1 and 2. 3, 2. ఇక్కడ 3 ఒక్క నిమిషం. See here. The item set should be greater than MS of A, and support of H minus support of L should be less than or equal to 5. According to this rule, algorithm lo undi. Support of 3 is 6% and support of 2 is 25%, and the difference should be less than 10%, but it is greater than 10%. మీకు ఇక్కడ rules see up to here we have find the L values and you have understood how to take the L values. In the next case, you are taking the frequent items F1 you have generated and level 2 candidate generation. You are considering which items to be taken, and 1 and 2 we are not taking because it is not satisfying the minimum support. And then the next stage 3 2 is you are not considering because it is not satisfying the constraint of 5. You need to consider all the constraints. Okay, any other doubts? So how, first thing, what is the difference between the general a priori algorithm and this algorithm, minimum item support algorithm? In the first stage, for generating the frequent item sets, the first step is to sort the items according to their MAS values. Then once you have sorted the items according to their MAS values, then you need to find the frequent item sets from the L value. So before finding the one item set F1, you are finding the L values. So for generating the L values, the rule you are following is for all the subsequent values in M, the J count should be greater than the MAS value of I value. So using these rules, you are generating the F1. Then after generating the F1, you are going with, you are generating the C2, and in C2 also you are checking whether they are frequent or not, and you are also seeing the constraint of 5 over it. Is this point clear? ఫస్ట్ రూల్ జస్ట్ ఎంఎస్ వాల్యూ కనుక చూస్తే మన F1 ప్రాబ్లం ఎలిమినేట్ అవుతుందేమో, కానీ F2 ప్రాబ్లం ని కూడా ఎలిమినేట్ చేయడానికి వీఆర్ ఇంట్రడ్యూసింగ్ అనదర్ కన్స్ట్రెంట్. ఓకే, సో ఆ కన్స్ట్రెంట్ యూజ్ చేసుకొని ఏవి ఎలిమినేట్ చేయాలి అని చూసుకుంటున్నాం మనం. ఎనీ అదర్ డౌట్స్? This is little bit confusing. If you have any doubts, ask me. So everyone understood. MS candidate generation function. So it has joining step and pruning step. So up from 8 to 12 are pruning steps. Confuse అవుతారు. Shall I proceed? Because even this slide is more confusing. Shall I proceed or stop?
Ma'am, stop, ma'am.
Okay. ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా. ఎనీ డౌట్స్? (23) ప్రెసెంటా? 22? 22. Okay, right. So, thanks for the day. Thank you.